How's it going, Eliminators? Today, we're going to be discussing a bunch of different V-belts, from your industrial V-belts to your OEM or original equipment manufacturer's belts. Those are going to be the belts that you get with the equipment that you purchase from big box stores, stuff like that. And we're also going to be discussing some Aramid and Kevlar belts as well, and why I would highly recommend using those belts because they're a little bit stronger if you can use them in your application. So with that being said, let's get right into it. So I have a bunch of different V-belts in front of me today. All of these V-belts can fit a wide variety of different equipment, and some of them have subtle details that are going to be a little bit different from the other. So I'm just going to be going through them one by one to compare them. So for the most part, when you're looking at V-belts, you're going to have three main categories of belts. This is going to be your industry standard belt. Then you're going to have your small engine industry standard belt. That's going to be what an OEM or original equipment manufacturer would use on their equipment. And then you're going to have a Kevlar belt or something similar with a little bit stronger fibers. We're going to get into that momentarily. For now, we're just going to discuss the basic industry standard V-belt that is used in industrial applications. So starting out with this belt here, I called it an industry standard belt. What does that really mean? Well, this is a belt that's going to be primarily used in an industrial setting. The main purpose of this belt is essentially to transfer power from a drive pulley to a driven pulley. And there's not going to be any external forces pushing against the belt, which, us in the small engine world would consider, let's say, an idler pulley to put more tension on the belt. A perfect example of this would be my air compressor here. So we have an electric motor here. That's going to be your drive pulley. And then we have the compressor over here, and that's going to be the driven pulley. And there is a belt that connects the two pulleys together to transfer power from the motor to the compressor. And there are no external forces pushing against the outside edge of that belt. And again, that is just going to be your standard industrial V-belt. This belt and many like it are built with, basic materials. This is generally going to be a rubber composite belt, so a composition of many different materials, but for the most part, you'll always hear me refer to one of these black, basic belts as a rubber composite belt. And these, a lot of times, do not have an outer cord that has been molded into the belt itself. So on the belts you're going to see me show you in a moment, you're going to see a cord, which I can move over here. You might see one right in here. So those cords have been molded into that belt to give it a little bit of extra strength. So coming back to the industrial standard V-belt, again, not a lot of outside tension, one main purpose, transfer power from one pulley to the other. That's it. Now, these belts are typically sold at your TSC stores, so that's going to be your tractor supply stores, and you're going to see them in some places in Canada, like a Princess Auto, which in the United States would be a Harbor Freight. These are very cheap. A lot of times they're going to run you like $6, $8, maybe $10, and I have to, on a lot of times, encourage my customers against using them, and that is because they're built so cheap, and they do wear out very quickly, and they can also break, have premature failure issues, have premature tearing at the seam where the belt is joined together, which we're going to discuss shortly. But for the most part, you do not want to be using these cheap belts on your small engine equipment. And even though you may not see the cords in these cheaper industrial V-belts like you would in some other belts, which we'll get into in a moment, there's still going to be cords that are formed inside of this belt here. So if I was to cut this and show you a cross section, you would still see some cords along the top edge. But a lot of times what you're going to notice with these industrial V-belts are they're not going to use as many reinforcement cords, and the material of those reinforcement cords are going to be a lot less than some of the other belts that I'm going to show you here today. Now, moving on from the industrial V-belt shown on the right, we're going to be having a look at what you will a lot of times hear me refer to as an industry standard V-belt. Now, this industry that I'm referring to is not an industrial industry. It's going to be the small engine industry. So this is something that a lot of OEM manufacturers are going to use. These belts are generally the same material as the industrial V-belts here. They're going to be a black rubber composite belt. They're going to be made up of various materials, but the main difference that I showed you is they are going to have that reinforced cord that goes around the outside. Now, what that cord does is it helps the outer force of an idler pulley pushing in to put tension on the outside edge of that belt. So it gives the belt a little bit more strength. If I move over from that belt there to this one, the cord inside is much more visible, right? So they're going to lay that in there, and this is generally made of polyester, that cord there. So it's a polyester cord that's been laid into the belt during the molding process. And again, that's just going to enhance and give the belt a little bit more reliability for that external idler that puts tension on the belt. So moving from something like a compressor, where again you just have that belt circling the pulleys and there are no idler pulleys pushing on the outside of the belt, you're going to see that belt used on something like a snowblower's auger. So you have this idler pulley, and this is for your auger. So when you go ahead and engage the lever, it pulls on a cable that pushes this idler pulley into the outer side of that belt, which then puts tension on the belt and then transfers power from your drive or your engine pulley here down to the second stage pulley on your snowblower's auger. So again, a polyester corded rubber composite belt is going to be referred to as the industry standard when it comes to small engine equipment sold by manufacturers who need something that's a little more stronger than just your typical industrial belt, but don't want something as costly as a Kevlar belt, which we're going to get into next. So if you watch my videos, you're commonly going to see me using Sten's True Blue belts, and you're generally going to be hearing me referring to them as Kevlar belts, even though Sten's True Blue belts are not Kevlar. The technical name for these blue belts here are Aramid belts. That's A-R-A-M-I-D. Now, Aramid is a fiber, and it's incredibly strong. It has a high tensile strength. So unlike the polyester cords that you saw in this belt, these belts here have Aramid fiber cords that go through them. These blue belts will last longer than your industry standard polyester corded rubber belts, and obviously will last much longer than your industrial belts over there. The big thing that I hear a lot of people, have some confusion about is the difference between Aramid and Kevlar belts. Now, having a look at the packaging, you're going to notice the words dealer's choice. That's simply the company that's distributing these belts. Now, in their own product number shown here, you're going to see the number 3. That's going to signify to me, the buyer, that it is a 3/8 belt. We're also going to see the letter K. That is going to signify to me that it is a Kevlar belt. However, you'll notice that they don't actually use the word Kevlar anywhere on this packaging. And that is because Kevlar is a trademark name. So back in 1965, the DuPont company trademarked the word Kevlar as their own brand of product. And essentially it is their own, makeup of Aramid fibers. It's their own blend, their own weave, and they've trademarked that. Now, a lot of times you're going to hear people referring to these blue belts under a bunch of different names. Sten's True Blue, which is going to be your basic Aramid belt. You're going to hear the word Kevlar. Sometimes you may also hear Nomex or Technora. These are all different names that have essentially been branded, except when you hear the word Aramid, those are actually the fibers of the belt themselves. So in the case of Sten's, which I am a Sten's parts distributor, they went out and just branded their belts True Blue. That's basically their own branding, and you guys will see me talking about and using Sten's True Blue belts in a lot of my videos. Dealer's choice belts I get from Power Source. So when I'm ordering Briggs & Stratton parts, if I want to order a belt, you'll see the Dealer's Choice logo there. For the most part, though, I do use quite a bit of Sten's belts. You guys can see whether they're Kevlar or not. Now, going back to this packaging here, you're going to notice that they use the letter K to describe it as a Kevlar belt, but Kevlar, the word, is not mentioned anywhere on this packaging. And again, that goes back to Kevlar being a trademark name. So if Dealer's Choice wanted to sell one of their belts as an original Kevlar belt, they would have to license that from DuPont, and they are going to have to pay a licensing fee. That means that their belt would end up costing more than an Aramid belt, which is essentially going to be the same thing. So whenever you are watching my videos and you see me using one of these blue belts, I'm just going to generally refer to it as a Kevlar belt. Again, they're going to be much stronger than your industry standard belt over here that just has that polyester cord. And these belts are going to be heat resistant. So Kevlar belts have been designed to be heat resistant. They can withstand extreme temperatures, and they also have an extremely high tensile strength because of those Aramid fibers meshing into each other. And Kevlar belts have also been designed to withstand that outer force of an idler pulley. So again, going back to a snowblower here, if you can use a Kevlar belt in your application, which I'm going to talk about in a moment, then I would highly recommend it because again, it's going to withstand higher temperatures and it's going to last a lot longer because it's going to be a stronger belt. Now, with that extra strength also comes a higher cost. So these belts here are typically going to cost more than this belt here, which would then cost more than this belt here. Just imagine that all of these belts were the same size. You're going to have price increases with each one. Now, without getting too scientific, there are differences between a real Kevlar belt and a standard Aramid belt. So there's going to be differences in the blending, the materials that they use. Obviously, Kevlar is going to have a proprietary design when it comes to the Aramid fibers meshing in with one another. They could have a proprietary weave and also any kind of binding agents that they use in the belt itself. So when we think of Kevlar belts, they are technically called a para-Aramid, while a Nomex belt is called a meta-Aramid. That's just going to be the difference in their own proprietary designs. But for the most part, again, without getting too scientific, for your average consumer, go ahead and buy an Aramid belt. If it's blue and it says Aramid on it, it's going to last a lot longer than your standard rubber composite belt with a polyester cord. So going back to the beginning of my video and when I was just showing you the snowblower, I mentioned that I would always recommend a Kevlar or Aramid belt over your standard industry belt if you can use it in your application. So what did I mean by that? Why can't you simply run a true blue Stenz belt in replacement of your standard belt that comes off of your snowblower? Well, there's going to be a couple different things here. One of the main things is going to be these sizing differences here. So you're going to notice that this belt here, I've written the numbers down. It's a Toro belt, but the size comes out to a 3/8 by 33 1/4. Now, over here, we have a 3/8 by 33 belt. And again, this is going to be like your Kevlar Aramid belt. So one of the main things is you cannot buy, from what I can tell, at least from Dealer's Choice or from Stenz with their True Blue line of products, you cannot buy an Aramid or a Kevlar belt in an in-between size such as this. So you can only buy an Aramid belt in a whole size. So it has to be 3/8 by 33, 3/8 by 34. And that can cause problems when you're trying to use a Kevlar belt or an Aramid belt on your particular application, because you may have a machine that requires a 3/8 by 33 1/4 belt, and that extra little 1/4 inch may make a difference. But I'm going to show you a trick in where you can apply these Kevlar, Aramid belts to your machine without having any issues. So moving back to the Yardworks snowblower from my previous video, I ended up tearing it apart. It was in fact the governor spring. You guys can see all the stuff we had to pull apart to gain access at that. The governor spring, unfortunately, is on back order, so we're trying to find one locally, and we're going to get this thing fixed up. But what I want to explain to you is a little trick that you can use to get yourself a Kevlar belt on your equipment instead of running one of those standard rubber belts that have that in-between size. So a snowblower is actually a perfect machine to use to go ahead and explain this. So generally speaking, on a snowblower, you're going to have two different belts. At the back, you're going to have your drive belt, and at the front, you're going to have your auger belt. Now, knowing whether your belt engages and disengages, or like the drive belt on the back of the snowblower, should always be in the engaged position, that's going to be vital to trying to get a replacement Kevlar belt onto your machine if your belt is one of those in-between sizes. Now, the belt sizes that I'm going to mention shortly aren't for this machine, so keep that in mind. But let's imagine that this drive belt here, which is always under tension via this idler pulley, was a 3/8 by 33 1/4. Well, you can't get a 3/8 by 33 1/4 in a Kevlar belt. However, as you saw, you can get it in a 33. Now, what you could do is replace this belt here with that Kevlar replacement belt or Aramid belt, and it's going to be a 1/4 inch smaller. Now, what that's going to do is it's going to move your idler pulley out slightly. So it's going to be putting a little bit more tension on your idler pulley spring. However, you don't have to worry about the belt grabbing because it's a smaller belt, because that belt has been designed to always stay engaged. Now, on the flip side of that, you're going to have a belt that has been designed to be engaged and disengaged. That means that this crankshaft pulley up here must spin all the time without engaging this belt. And then whenever you want to throw some snow, you have to manually engage that idler pulley to put tension on that belt to transfer power. So if we pretend for a moment that this belt measured a 1/2 inch by, let's say, 38 1/2 inches, and you wanted to replace it with a Kevlar belt, you could only get the size down, which is going to be a 1/2 inch by 38 inches. Now, you may not think that a 1/2 inch or let's say a 1/4 inch could cause an issue or be a big deal, but on a belt that's going to engage and disengage, it could cause a grabbing issue. So if you go ahead and take a 1/2 inch out of this belt, what you could notice is you go ahead and fire up your engine and your crankshaft here starts spinning this pulley. A 1/2 inch shorter on this belt could lead to that pulley grabbing this belt, right? Even when your auger lever or your idler arm is disengaged, that belt now could be to the point where it's a little too short and it's going to start grabbing and you're going to start to smoke out your belt, and you might even notice your auger turning up front in your auger housing. So when it comes to a belt that engages and disengages and it just happens to be one of those in-between sizes, you're probably not going to be able to run a Kevlar belt that's shorter unless you went ahead and replaced this idler pulley with an idler pulley that had a slightly smaller diameter. But I don't really recommend that. Now, one of the reasons why I don't recommend that is because I've had a lot of confusion before when I get equipment that someone else has worked on and someone else has done that. So they go ahead and try to get a replacement belt. They don't have the right one in stock, but they have one that's slightly smaller. So what they do is they go ahead and put a smaller idler pulley on it. Let's say it's a riding lawnmower on a mower deck, and then when I go ahead to put the original belt on, it doesn't engage properly, and now I have to search for what the problem is. So again, if it's your own equipment, you can go ahead and do it, but if it's somebody else's, I wouldn't recommend it. So as I mentioned with that mower deck on the riding lawnmower, the same principle is going to apply when you have a manual PTO. So if you have a riding lawnmower that you have to physically push a lever to engage the blades, what that's doing is it's pulling on a cable or moving a lever that's going to manually engage an idler pulley. And that idler pulley is then either going to push to put tension on your belt, or it's going to release the tension on that belt. And the reason why you don't see a Kevlar belt here is just because of that fact there. So on this mower deck in particular, the belt has to be one of those in-between sizes. I forget exactly what it was, but I believe it was one of those 1/2 inch in-between belts. And you just can't run a Kevlar belt that's a 1/2 inch shorter, because what'll happen is when you fire up your engine, the engine might spin a little bit slower. It might be harder to start up. And that's because the belt here is going to be grabbing against the engine's crankshaft, which the drive pulley is located on for the mower deck belt. And if that happens, you may also notice that your spindles start to rotate. However, if you have your blades disengaged, you're going to notice all these linkages here. They go to your spindle brakes, So if this is in the disengaged position, but you have a smaller, shorter belt on it and your spindles are turning, they're going to start wearing out your brake pads. Now, if you have a riding lawnmower that has an electronic PTO clutch on it, then you don't have to worry about this. If you had a belt that was one of those in-between sizes, you can downsize a 1/4 inch or a 1/2 inch smaller belt, because a riding lawnmower with an electronic PTO clutch is going to have a belt that's always engaged. There is not going to be any manual engagement or disengagement. So going back to the snowblower's drive belt, what you're going to have with a riding lawnmower that has an electronic PTO clutch, if you go ahead and run a slightly shorter belt, it's just going to put a little bit more tension on that idler spring, because you're running a slightly shorter belt. That's going to cause a little bit more tension. But for the most part, whenever I've downsized in a belt, I've never had any issues. But I just wanted to go ahead and show you guys that example there, so that you know not to downsize a belt when you have the manual engage or disengage. And then similar to you not being able to get a Kevlar or Aramid belt in the in-between sizes, you're also not going to be able to get Kevlar belts in a specialty belt such as this. We have here your basic cogged or tooth belt, as it's called. So on a lot of snowblowers, you'll see them run a 1/2 inch or even a 5/8 auger belt. But on a lot of MTD models, you'll see them run 2 of these smaller 3/8 belts, and sometimes they will be cogged or toothed like this here. So this belt, you can see there's still going to be the polyester cords in them. So this is your typical, small engine belt right here. This one is from Stens. It is an MTD replacement, and these are tooth belts. So what these belts do is they offer a little bit better flexibility for the belt to bend around the pulley, because you guys can see there in those cuts, they compress just like that, right? So you're going to be able to get this belt around a much smaller pulley. It's going to grab a hold of that pulley better. But one of the big things is the improved cooling, because what you're going to have is where the belt is not engaged. So imagine if it was like this. Wherever the belt is not engaged, you're having more surface area exposed to the outside air. So what that's going to do is allow the belt to cool down faster, which will increase the life expectancy of this belt here, give it a little bit longer reliability. And yeah, these belts are pretty good. I've generally never had an issue with them. A lot of snowblowers from MTD have that, Cub Cadet, White Outdoors, you name it, Yardworks, even all the MTD products. A lot of them run these dual cog belts. And again, you won't be able to get a Kevlar replacement if you are having these specialty belts on your equipment. And before I wrap things up, I just wanted to add that a lot of these belts are going to be joined at a seam. You guys can see it here, that diagonal line that's going across the belt. So that's where they've joined these 2 ends together to make your belt into a loop. And Terrell Fixes All, he's another small engine repair channel here on YouTube. He actually did a very good video explaining why your belt would snap at this location or any other location if you had something like a mower deck belt and it just decided to let go. Basically, what he says is that if you do have a belt that just happened to let go at that seam or anywhere else on the belt for that matter, what's happening is when you're cutting grass, you're going from a state of not cutting grass into an area where there's a lot of grass, and you may be overloading your blades and your spindles to the point where your belt is going to tension up, and then it's going to become slack, and then it's going to tense up again. And that slapping of the belt creates too much pulling force, and it just basically rips the belt in two. And that's, going back to the increased tensile strength of a Kevlar belt. It's going to hold up a lot better than, your rubber composite belt that the manufacturer shipped your machine with. However, even these belts here, the Aramid or Kevlar ones, still are going to be joined at a seam similar to this belt here, right? All of these belts are made in a certain length. They're cut to length and then they're joined together. So this, just like the master link on a chain, is going to be the weakest spot, and you could always have a failure there. I know that Stens does offer, I believe, a 2-year warranty on all their True Blue belts. However, I haven't really tested that out. While I haven't had any issues with a Stens True Blue belt failing, sometimes you're going to get a stick into your riding lawnmower's mower deck that's going to wedge itself in, and you're going to end up blowing a Kevlar belt. It happens. These things aren't indestructible, But again, guys, like I've tried to show you here in this video, these are definitely worth the added cost. And I would highly recommend them over your standard rubber composite belt. So without getting too technical or too scientific, I just wanted to take a little bit of time to explain the main differences behind these belts and tell you a little bit about what you would need to know as a consumer. Again, I would never recommend one of these cheap belts, so please don't go out and buy them. I know over there in the United States, these things could be like $6 or $8, and the price is really entertaining, but unfortunately, just the reliability isn't there, and that's because they just haven't been designed for this high load application where you could also be getting a little bit of more heat. And that's another thing where this manufacturer's belt has been designed to withstand that outer idler pulley pushing against it, and that pulley pushing on this belt is going to create more surface friction, which is then going to create more heat. So then, moving on to the Aramid or the Kevlar belts, these have been designed to be heat resistant. So you guys can be running these, especially on a mower deck belt that has all these pulleys interfacing with these belts. Go ahead and get yourself an Aramid or a Kevlar belt. Spend a little bit of extra money and you're going to have a belt that basically just lasts a lot longer. And even though this material is pronounced Aramid, you may sometimes hear me refer to these blue belts as Aramid, and that's just me getting a little bit tongue twisted, so don't pay any attention to that. Well, that's going to be it for today's video. Again, without getting too technical, I just wanted to briefly explain some of the differences between the belts, and again, why I recommend using an Aramid or a Kevlar belt. They just last longer. I know they're a little bit more money, but in the end, the reliability outweighs the cost. Usually they're only going to be like 10 or 20 bucks more. If it's a really long belt, you're not going to be paying that much more over the cost of a standard rubber composite belt with a polyester cord in it. With that being said, if you guys enjoyed the video, think about leaving me a thumbs up. It really helps me out. You can click here to subscribe and click over here to watch one of my previous videos. I upload every single week, so be sure to stop on by next week. Check channel out for new content. And as always, guys, thanks for watching.